Good evening, everyone. Hello. Yeah. I just having so I fixed my audio problem. So yeah. Good evening, everyone. Welcome to the live interaction session for the week 4 for the course Nanotechnology in Agriculture. My name is Amir Akle. I am the Prime Minister Research Fellow in the Department of Mechanical Engineering, IIT Tirupati. Uh, I hope my screen is visible and my voice is audible. The course instructor for this course is Professor Mainak Das, professor in the Department of Biological Sciences and Bioengineering in IIT Kanpur. This is the fourth week of the course, and we are taking the fourth content related to fourth week. So before we begin, some formalities like always. This live interactive session is to boost your performance. It is not compulsory, but it is highly encouraged. Please be respectful in the chat. Questions can be asked at the end of session. You can also ask questions related to the previous assignments, uh, which have been already submitted or which have been actually closed till by now. By today's session plan, we'll be starting with a discussion of the practice assignment 4. We'll move to question and answers where you can ask your other questions as well. So this is a 8 week course. We are in the fourth week, so we are basically completed with 50% of the course. So this week's content is application of nanotechnology in modern day agriculture practices. The second part. Next week we'll be having application of nanotechnology in animal production. Then we'll be having nanotechnology and shelf life in of agriculture and food products. So we have a interesting topics coming up. Let's not waste time and let's start with the practice assignment for the fourth week. So the question is dash is tagged with AU NRs, that is gold nanoparticles for MRI, theranostic, and imaging. The elements are given here: gadolinium, that is GD, lithium Li, molybdenum MO, or magnesium Mg. So, any guesses? So, yeah, the answer is gadolinium. So basically, this is how it looks like. So basically, we use gadolinium shellate, so we can call it as the nanoparticle. Then over that we coat the drugs and the polymers and the target agents. Basically, everything is coated on the gadolinium nanoparticles. Then basically they are injected at the tumor site. So uh, using that, yeah, basically you can either diagnose as well as you can also do the therapy. Basically it can penetrate towards the tumor, or you can also use it for diagnostics. So this is how a process looks like. So basically we use gadolinium nanoparticles, we coat it with drugs and everything, and then we use it for the application. So basically, theranostics is basically a word that combines therapeutics plus diagnostics. So basically, that is called as theranostics. So maybe you can even read about Elizabeth Holmes, which is a wonderful read. You will find out what how human greed can actually change everything. So Theranos is a very uh, like feared word on the Wall Street. So you can actually read about Elizabeth Holmes, and you will basically find out why it is. So if you have any free time, maybe you can watch some documentary or you can read about her in your free time. So this is the answer is gadolinium, gadolinium. So we'll move to the next question. Compared to monocot plants, the dicots show higher uptake of nanoparticles due to more permeability in the roots, permeability in the cuticles, permeability through water channels. So, any guesses? Okay, so the answer is permeability in the cuticle. So basically, you can see how the cuticle, how the various structures looks like. So from this you can see actually that the cuticle has a very high permeability. So basically, due to the permeability of the cuticles, it is able to like absorb all the nanoparticles. So that is what.
গড়িয়াহাটের ওর প্যানেলটা ডিস্টার্ব কোনটা বলুন তো গড়িয়াহাট ওই যে স্টুডিও আবার ফোন করেছে না ওই আসছে যাচ্ছে আসছে কি আসছে যাচ্ছে প্যানেল লাইটটা না না ওই একটু তেল দিতে হয়
So that is why the answer is permeability of the cuticle. So you can see here the various structures and how permeable they are. So basically, you can see that the cuticle has the highest permeability. Okay. So moving to the next question, the leaves of monocots have parallel veins that are most resistant to tearing and therefore have high strength, low strength, high permeability, more water pores. So this is basically a very easy guess. So please at least guess in this question.
High permeability.
No, here they have given they are resistant to tearing, and so wo- when they are resistant to tearing, what will be the like uh, the output? So it will basically it will have high strength, right? When
Yeah,
the
high strength, right?
yeah, so this is how the thing how the testing is done. So basically, uh, for tearing, so what is tearing? So basically the strength is basically the resistance to failure. So whenever we call something this material is strong or this material is weak, so what is the parameter that is used? That is one is the parameter is basically resistance to tearing. So basically the more it is difficult to tear, more strong it is. So basically, what the main mechanism through which the failure happens basically is called as crack initiation and propagation. So basically, when you initiate one crack and how easily it propagates. So basically, in a parallel vein structure, what we see is the propagation of crack becomes very difficult. So because the crack propagation is very difficult, the material is very difficult to tear, and then that gives out better strength. So what is the main benefit of parallel veins is basically it prevents the crack from propagating. So even if there is a crack in one place, so there will be a crack somewhere or the other that will be generated, because basically the entire structure will have some micro cracks which will get bigger. And but what happens is the parallel line structure uh, prevents the propagation of the crack. So that is why they have a high strength. So the answer is high strength. These are the other tests which are done. So these are the punch tests, and these are also the shearing test are also done. So punch test is basically you keep the leaf and then you punch it. So basically you can see like how the punching how the setup looks like. And in the shearing, basically shearing is basically tearing. So how you tear a book page? So if you are using a book, so in shearing, what you do is how you tear apart some like a book from your page, how you will be tearing it apart, that way it is. Whereas in the this tearing test, which is actually tearing test, you will be actually pulling it apart. So in the tearing test you'll be pulling it apart, and the shearing test you'll be like what you can say is just using something like that will be on the axis of the um, leaf. So we move to the next question. These are like very basic questions. Drought resistant plant develop tighter cell walls, cuticles, uh, Casparian strips, and other barriers that help minimize dash during dash conditions. So nutrient loss, scarce water, water loss, low water, gas loss, scarce water, ionic gain, scarce water. So any guesses? Okay. So this is a very simple question. So we all know this. We all know the answer. So basically, it is the water
Less and
loss.
low water.
So in basically, yes, the answer is water loss during the low water conditions. Um, Moving to the next question, the some of the essential factors of the soil, such as organic matter and humic acid, make the materials dash, which dash. So basically, whether it makes the nanomaterial less stable, which conversely it decreases their bioavailability. Ionically stable, conversely, which enhances their ionic activity. More stable, conversely, which enhances their ability to generate free radicals. More stable, conversely, which enhances their bioavailability. So basically, the answer is more stable, which enhances their bioavailability. So basically, the essential factor in the soil. So basically, what this me intends to say that if the soil is if you are using some organic matter in the soil, it will not affect the nanoparticle performance, but it will actually make it better because it enhances their bioavailability, because it tends to stay longer. So basically, like it doesn't get a burst release; it gets a sustained release. So that is what uh, the uh, the question intends to say. So next, any questions till now? I don't think any questions. These are very easy questions, but yeah, if any questions you can ask. So moving to the sixth question, the transport of copper oxide nanoparticles from root to shoot and its reverse transport from shoot back to roots takes place via xylem, phloem, and phloem respectively, xylem and water channels respectively. So basically, whether it takes place through xylem, whether it takes place to phloem, whether like what the third option is like from root to shoot takes place through xylem, and from reverse transport takes place through phloem, and whether it takes place through xylem and water channels or respectively. So the answer is xylem and phloem respectively. So basically, from root to shoot, it goes from xylem, uh, like through the xylem, it goes from root to shoot, and coming back, it comes from phloem, from the shoot to the root. So this was discussed in the lecture. So this is how the uh, a basic structure works. So over the if it goes up and if it comes down through the another channels basically. So yeah, question number 7: a significant anatomical difference between a dicot and monocot in the leaf architecture, such as the presence of dash in the monocot and dash in the dicot plant, resulting in variable degrees of uptake and translocation efficiencies of nanoparticles. Dumbbell-shaped stomata, kidney-shaped stomata, kidney-shaped stomata, dumbbell-shaped stomata, dumbbell-shaped stomata, circular-shaped stomata, dumbbell-shaped stomata, Z-shaped stomata. So basically, this was discussed again in the class only. So the answer is A, dumbbell-shaped stomata and kidney-shaped stomata. Basically, in the monocot, there is a dumbbell-shaped stomata, and in the dicot, there is a kidney-shaped stomata. So that leads to a difference in the um, uptake. So what will happen is, depending on the structure, the area available. So in nanoparticles or in nano chemistry, basically the area which is available plays a lot of role. So surface area to volume ratio plays a lot of role. So you can see from this, like the shape, because of the shape of the stomata, the resulting like degrees of uptake and translocation efficiencies change. So this is how a monocot leaf looks like, and how a dicot leaf looks like. So basically, you can see from here only. So moving to the next question, the assimilation and concentration of ferrous oxide, that is iron, Fe3O4 nanoparticles in pumpkin, Cucurbita maxima in plants were quantified by employing a dash to confirm the functional presence in the roots and leaves. XPS, centrifugation, vibrating sample
ठीक है मेरा अच्छा
magnetometer. Hello, hello,
हेलो
hello. Sorry for the inconvenience. So, uh, I'll repeat the question again. The assimilation and concentration of iron nanoparticles in pumpkin, Cucurbita maxima plants were quantified by employing a dash to confirm the functional presence in roots and leaves. XPS, uh, in centrifugation, vibrating sample magnetometers. So, just to give an example. So I think many of you might not be knowing this technology. So we'll go one by one through all the technologies. So first is XPS. So that is X-ray photoelectron spectroscopy. So basically what it does is basically that is used for surface level characterization. So if you, that is used in, like, if you have any surface and if you want to quantify the coating properties and all those things. So for that you use X-ray XPS. So that is basically surface level characterization technique. Centrifugation is not a characterization technique. It is a normal technique. It is normal biological process. So basically, what you do is you put the sample in a falcon tube or a test tube, basically, and you rotate it very fast so that there is a phase separation that is occurring. In the vibrating sample magnetometer, basically you make the sample vibrate, and you have a magnetic bars on the edge that will be able to separate the magnetic material. So basically that is used in separating the magnetic and the non-magnetic materials in a like, if there is a phase which has magnetic and non-magnetic materials, then this is a highly used. Same is a basically it's a it's an imaging technique. So that is a scanning electron microscopy. So basically that is used for looking at the surface level or any in nanochemistry also. It is used in basically morphological characterization. So basically what you do is you put the sample into the SEM, you get an image, so you get to know the morphology of the surface. So if it's a nanoparticle, so in case of nanoparticles, it is used in a lot of things. You can see the morphology, you can see the structure of the nanoparticles, and you can also see whether it's agglomerated or non-agglomerated. And you couple it with EDS, you can even find out the elemental composition. So whenever you go for SEM, basically if you go for SEM for your characterization needs, you will see SEM plus EDS. So basically SEM is used for the surface morphology, and EDS is used for the elemental composition, that way. So from this, here you have a material which has iron nanoparticles in the pumpkin plants. So how will you use it? So you have a magnetic particle and you want to find the concentration. So uh, using SEM, can you find it out? Like, you are having a photograph. Can you find out how to whether you can you find out the composition from a photograph? Can you get a quantitative data? No, right? From centrifugation, can will it be possible to separate something that has been impregnated into the tissues? Or using XPS, again, that is only the surface level data you will get using XPS. Can you do it? So from this, what do you think will be the answer? The answer is vibrating sample magnetometer. So this is how the structure looks like. So basically, you have the magnet at two edges. You put the sample, and then you have the vibration unit to vibrate the sample, so that you can just tear apart the sample and you can just get what you need. So basically, this is how the structure. This is how the vibrating sensor vibrating sample magnetometer looks like. If you have any questions regarding other characterization technique, then unmute yourself and ask right now. Or else we'll move to the next question. So we'll move to the next question. So the major problem with tracking and translocation of ferrous oxide nanoparticles is associated with the inability to distinguish between the intact Fe3O4 nanoparticles and these ions, which can further be solved by using magnetic particle spectrometry in conjunction with conventional atomic absorption spectrometry, XRD in conjunction with XPS, TEM in conjunction with XPS in conjunction with FTIR. So now, what this wants to ask is basically there are if you have two type so you have introduced iron oxide nanoparticles inside a structure, biological structure. So now there'll be so not everything will get like leached, so not everything will get dissolved at the same time. So what you need to do is you want to track what has happened, what you want to track the current status of the system. So you have so how will you do it? So which of the techniques will you use? So magnetic particle spectrometry in conjunction with conventional atomic absorption spectrometry, XRD, that is X-ray diffraction in conjunction with XPS, that is X-ray photoelectron spectroscopy. TEM, that is transmission electron microscopy in conjunction with X-ray photoelectron spectroscopy. X-ray photoelectron spectroscopy in conjunction with FTIR. So, I'll just explain to you what each of the technology does. So basically, we'll start with TEM. So TEM is a microscopy process like SEM. It is basically uses electrons. Just the TEM has a higher resolution, and basically it is widely used in nanoparticles. XPS, again, as I explained to you, X-ray beam will be used. It will be incident, and then you will have the photoelectron getting emitted from the surface, and that photoelectrons will be measured by the spectrometer. So in XRD, basically it has X-ray diffraction. So basically you have an X-ray incident on a material. Based on the crystal structure, there will be the the diffraction. So there will be different diffraction angles. So based on that diffraction angles, you will get a diffraction pattern. So that is basically it is widely used in finding the crystal structure of any material. XRD is widely used. There are other applications as well, but it is mainly used in the finding the crystal structure. And FTIR, basically it's called as the Fourier transform infrared spectroscopy. That is basically it's a process used in finding the functional group. So if you want to find out any functional, if you have given any material and if you want to find out the functional groups in a polymer, basically, then FTIR is widely used. So magnetic particle spectrometry, basically it is used in the magnetic particles. You use it for the spectrometry of the magnetic particles. From that you can find out. And atomic absorption spectrometry, basically it measures the so it has two let's say uh, it compares the sample with the control sample and gives out what atoms have been absorbed in that. So basically you will have a blank, and then you will have your sample, and then you compare it and you get the reading. So what do you think will be the answer from the process description? What I said, what do you think will be the answer? Okay, no worries. The answer is magnetic particle spectrometry in conjunction with the conventional atomic absorption spectrometry. Because obviously we want to know the magnetic particles, so how, whether they are intact or not. So basically, when the Fe3O4 nanoparticle is intact, it will have some magnetic properties. So that is why you use magnetic particle spectrometry. And conventional atomic absorption spectrometry is to basically know the leaching. So basically, you'll have the blank and you will have your sample. So in your sample, they'll tell you that this much. compared to your blank. So blank may be ethanol or something, and your sample basically they'll say that this has like compared to your ethanol, this has 10 times more iron atoms or something like that. So the process used is magnetic particle spectrometry, and in conjunction with conventional atomic absorption spectroscopy. Any questions? So why do you think there is any question in this? Then please interrupt me, or else we'll move to the next one. So last question here. Read the following statements carefully. The ability of nanomaterials to penetrate the hard coating of seeds and allow water incorporation is the deciding factor for increased growth and vigor. In addition to seed priming technique, with the help of nanotechnology, is a promising strategy before sowing. It further corroborates the potential of high yield value crops. The options are option A, only A is correct, only B is correct, both A and B are false. Both statement A and B are correct. So we analyze the statement first. The ability of nanomaterials to penetrate the hard coating of the seed and allow for water incorporation is the deciding factor for increased growth and vigor. So it's a correct statement. And again, the second statement, basically seed priming technique with the help of nanotechnology is a promising strategy before sowing. It further corroborates the potential of high value crops. So basically, what happens is, uh, whenever you have any seed, the number of seeds which actually turn into a plant has to be high, so as to get a higher yield, right? So when you sow 100 seeds, your at least 95 to 98 seeds have to germinate. So higher the seed germinating, you will get the better yield. So that leads to high yield value growth. So basically, using nanotechnology, you can ensure that you can, since it can like uh, even pass through the hard coatings of the seed. It gives it increases the plant germination capabilities, and it increases the growth and vigor of the crops. So the answer here is answer both answer statement A and B are correct. So did you miss any questions, or were you not able to understand any question? Please let me know. Uh, if you have any questions regarding, yeah, please. Debrata is here. You can ask your questions. In case you don't have any question, you can leave the session. Yes, sir. Debrata Banerjee, sir, you can ask your questions, sir. In case you don't have any question, you can leave. If you have any question, please. First question. Okay, fine. All right. So this is the question. So the ash is tagged with gold nanorods for MRI theranostics and imaging. So basically, for yeah, theranostics is basically a technique which combines both therapeutics and diagnostics. That is that is therapeutics, and gnostic is diagnostics and imaging. So basically, with my magnetic imaging. So basically, what it does is uh, just using MRI, you can find out where the drug is. So basically, it can be used for like tracking as well, and do all sorts of uh, like activities. So the options are gadolinium, lithium, molybdenum, magnesium. So the answer is gadolinium. This is how it works. Basically, you have the shellets. So basically, the nanoparticles of gadolinium that is coated with drugs and polymers and the target agents. So now, once it is inserted into the body, basically MRI machine will be able to track the movement. So if you have gadolinium, you are able to track where it is. Okay. So what happens is gadolinium allows for the tracking of uh, the drug which has already been put, and so when it reaches the tumor model, it can be used for diagnosis as well as therapy. So basically, depending on the magnetic power that we'll be using, you will be able to image the tumor. So basically, it will penetrate inside the tumor, and you will get the image of the tumor. So that can be used for further diagnosis, or you can burst it. So you can burst the you can see here the nanoparticles that has been made, that is coated with all the drugs and polymers. You can burst it at that area. That will lead to the therapeutic application. So that is how the entire setup looks like. Any other question? Yeah, please. Please.
Sir, theranostic means?
Yeah, theranostic is combination of therapeutics and diagnostics. So thera is therapeutics and diagnostic is diagnostic. So thera plus diagnostics, therapeutics का thera and diagnostics का ostics बना के they have made theranostics. So if you are interested, you can actually like how to scam people. If you want to see, you can just type in Theranos in Google. You'll find a wonderful documentary about a lady called Elizabeth Holmes. So that is something which like how using fancy words, how the people are scammed. You can actually look into it. So if you got time and if you have interest, like you can see how they have done it. So the theranostic is basically thera, which is therapeutics, and gnostic is diagnostics. So basically, this is a new branch of materials which will do both. So basically, they can be combined. So in this case, also you can see the gadolinium will reach the tumor, and then based on the magnetic strength you apply. So if you apply less magnetic strength, you will get the image of the uh, tumor. If you apply higher strength, the bubble, the nanoparticle will burst. So entire thing will burst, and that will lead to the delivery of the drug. So that is how the entire thing works. So it is a dual purpose material, you can say. So that is why it is called as the theranostics. I hope I was clear. Any other questions?
Okay, sir.
If you don't have any question, you are free to leave.
Sir, dicots and monocots parts, if you once again explain.
So this one?
It may be, yes. This one, sir.
This one only, na?
Yeah.
So, like, basically, dico- so basically compared to dicot plants, monocot dicot plants show higher uptake due to more. So basically, the cuticles of dicots have a higher permeability. So permeability basically is the pores between the like the tissue. So tissue obviously it's not like it's not a single material, right? It is basically the combination of cells, or what you can say as a group of cells. Basically, in dicots, the 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 cell gap, the gap between the cells is a bit higher in the cuticles of the dicot plants compared to the monocot plants. So that is why you will have a higher permeability in the cuticles of the dicot. So that leads to a higher nanoparticle uptake. So
Okay, sir.
that is how it is.
The third week video still not get, sir.
Third video not yet.
No.
I put there actually.
And the conclusion of this question, sir, the also not come to know, sir.
Yeah, that I did. I uploaded. So basically, that is
Last
not
week there was two doubt in two questions.
Yeah. That I know. That I upload. That I sent an email. So basically, I don't have any direct contact with the course guys. So I am from IIT Tirupati. They are from IIT Kanpur. So I just sent an email to them. I am also yet to receive any response from them. So you can also.
Sir, you can reach my email also, sir.
My email, yeah, you can reach me by email, but that I can't. I don't have any authority as such with respect to the course conduction. So basically, my job is to help you solve the uh, what you say, solve your assignments and all those things. But with respect to your course conduction, I don't have any authority. So that
Yeah, yeah.
authority lies with IIT Kanpur. So we are being delegated to just help you with the assignment solving. So how we can help you, how the questions are set by NPTEL and all, because we have some idea, and many of you might be new to NPTEL, or you might have been
So
giving the.
last week it is already loaded, sir, or not? I have seen before 2 days it is not loaded, sir.
Actually, I had loaded the video is uploaded. I think I missed out filling the form. I'll do. I'll just put the link right now itself. I'm just putting the link. I'll just put the link right now. Yeah, I'll do that. But the slides are visible, I think so. Slides I've uploaded. The, oh, yeah, no, sir. Video is uploaded, sir. To last week video.
Uploaded.
Yes, sir. Long back. I don't know
One back. I have seen last 2 days ago.
because you can see here. I'll just show in
2 or 3 days
my
ago
screen.
it was.
I'll show in
And
my screen. So you can see here week
yeah,
3, the video has been uploaded long back.
yeah, yeah, yeah.
Video, yeah.
But I have checked before 2 days or 3 days, sir. I
Okay,
not able to get it.
maybe that might be because I'll just check the link also that it's working or not. Basically, what I do is I finish the lecture and the next morning I upload it. So yeah, it's working, sir.
Yeah, yeah.
I usually I follow the routine. If I forgot anything, I also got afraid because if I don't do it, then I also get scolding from the NPTEL team. So I have to do it by Friday. So Friday is the deadline for always for me. So if I don't do, then NPTEL team will scold me. So I was also afraid about that. But
Okay.
yeah, so it's there actually. In case of any issues, you can just reach out to me on my email. But I have zero authority per se. I can solve your doubts. That's the only thing I can do. But other than that, if you are regarding your evaluation and all, I have zero authority. That lies with only with the professor. So even uh, and basically, so the professors are busy. So all the professors will be busy, so it will take time, but the thing should get sorted out because it's a big issue. So I have raised the email, I've sent the email to sir. We'll see what happens. I'll maybe send a gentle reminder, and you can also use the forum to raise the question.
Yes, yes, yes. Okay.
Okay, sir. If you don't have any question, you're free to leave, sir. Thank you. Anyone else has any other questions? I'll just skim through the questions once again so that we have a better. If somebody has come late, or if you have any questions. So, how many of you know all the characterization techniques? So, whichever characterization technique was said today, how many of you all know it? And if you don't know it, please ask. I can help you with that. Rather than skimming through all the questions, if you don't understand like FTIR, SEM, XRD, and all those things, if you don't understand it, just let me know. I'll just give you a brief introduction on all of them. So, what so if there is anyone like that who doesn't know all this technology, how they work, maybe I also want to get deep into how they work, but what they are used for basically. Then I can just maybe I can help you in that. So if there any question that any question like that, please let me know. Else we'll restart with the we'll just skim through all the questions once again. Okay. So the first question is Dash is tagged with gold nanorods, that is AUNRs. for MRI, theranostics, and imaging. So the options are gadolinium, lithium, molybdenum, magnesium. So the answer is gadolinium. So basically, this is how the entire thing works. So you have gadolinium chelates. You coat it with drugs. You coat it with polymers, basically DNA, RNA, whatever you want. Then there is the target agent. So that is the antibodies. So then basically you inject it into the body. Then it reaches the tumor site. So then basically uh, through the motion of the gadolinium nanoparticles. Basically, gadolinium is radio opaque. So you can find out where the tumor is. Okay, what is the size of the tumor? So that is how you find out. Uh, then, depending on the what you can say, the mm, magnetic strength which you are applying, you can get the size and dimensions of the tumor, or you can also use it for the therapy of the tumors, that is called as so you can just burst the nanoparticle and you can get the therapy done. So using the gadolinium nanoparticles, so that comes as the theranostic properties. You can either do therapy plus diagnostic. You can do both using the same materials, that is called as the theranostic particles. So the next question is basically, compared to monocot plant, the dicot show higher uptake in nanoparticles due to more permeability in the roots, uh, per, uh, permeability in the cuticles, permeability through water channels. So the answer is permeability in the cuticles. So this is the structure like of the basic all the materials. So you can see the permeability of cuticles is the highest compared to the other. So this is how the thing works. Um, Moving to the next question, the leaves of a monocot have parallel veins that are most resistant to tearing, and therefore have high strength, low strength, high permeability, low more water force. So basically, since they are resistant to tearing, they will be having high strength. So these are the few tests which are done. So basically, this is like punch test, tearing test, and the shearing test. So punch test is basically you punch a hole, you keep a leaf flat, and then you punch a hole through it. In the tearing test, you basically pull the leaf apart, and in the shearing test, you try to cut it, like shear it. That is like cutting it, basically. So like not cutting it per se, you can say it is like tearing it. Like if you are tearing a page, how it will be, that way it is. uh, so they'll so basically it's a parallel force in shearing. In tearing, it is a perpendicular force. So uh, what happens is basically in the tearing test. So basically, when you pull it apart, what happens is the reason for the failure is basically crack initiation and propagation. So basically, the crack is formed, and how well it propagates towards the through the transverse axis. So basically, in due to the parallel vein structure, uh, the propagation of the crack becomes very difficult. Very difficult. That leads to higher strength in the structure. So next, drought resistant plant develop tighter cell walls, cuticles, Casparian strips, and other barriers that help minimize dash during dash conditions. So the options are nutrient loss, scarce water condition, water loss, low water condition, gas loss, scarce water condition, ionic gain, scarce water condition. So the answer is water loss during low water conditions. Uh, Question number 5. Some kinds of essential factors of the soil, such as organic matter and humic acid, make the nanomaterials dash, which dash. So basically, less stable, conversely, which decreases the bioavailability. Ionically stable, conversely, which enhances the ionic activity. More stable, conversely, that enhances the ability to generate free radical. More stable, that conversely it enhances their bioavailability. So the answer is more stable, which enhances their bioavailability. The transport of CuO nanoparticles from root to shoot and its reverse transport from shoot back to root takes place via xylem and phloem respectively, xylem and water channels respectively. So the answer is xylem and phloem respectively. So basically, from root to shoot happens through xylem, and from shoot to root happens through the phloem. So the seventh question. The seventh question: significant anatomical difference between the dicot and monocot in the leaf structure, such as the presence of dash in the monocot and dash in the dicot plant, resulting in variable degrees of uptake and translocation efficiencies of nanoparticles. Dumbbell-shaped stomata, kidney-shaped stomata, kidney-shaped stomata, dumbbell-shaped stomata, dumbbell-shaped stomata, circular-shaped stomata, dumbbell-shaped stomata, Z-shaped stomata. So the answer is basically dumbbell-shaped stomata and kidney-shaped stomata. Basically, in nanochemistry, basically, or nanotechnology per se, the surface area plays a lot of role uh, on the overall mechanism. So a dumbbell-shaped stomata will have a better has uh, lower surface area than a kidney-shaped stomata. So basically, that will change the uh, uh, like uptake and how the nanoparticle works. So the efficiency also. So this is how the two leaf structure looks like, the monocot leaf and the dicot leaf. So you can see the dicot leaf has a higher surface area compared to the monocot leaf. So this leads to what you can say better nanoparticle uptake. So moving to the eighth question, the assimilation and concentration of iron oxide Fe3O4 nanoparticles, that is iron nanoparticles in the pumpkin Cucurbita maxima plant were quantified by employing a dash method to confirm the presence of roots and presence in roots and leaf. XPS centrifugation vibrating sample magnetometer same. So basically, XPS again, it's a surface level characterization technique. Um, Centrifugation, basically, it's not a characterization technique, it is a normal lab process wherein you just put your sample in the test tube and you rotate it very fast, and then you just see the phase separation occurring. Vibrating sample magnetometer, basically you vibrate this sample vigorously, and you collect the magnetic particles using the magnets. And SEM is basically a microscopic technique wherein you use a scanning electron. So basically, it's called a scanning electron microscopy. So basically, electrons are bombarded on the sample, and then you get the image by looking at the reflection, basically. So the answer is vibrating sample magnetometer. So this is how the vibrating sample magnetometer looks like. Uh, so you have a sample, you have the chamber, you have magnetic field, and you vibrate the sample so that you will see the samples going to the edge. Uh, so that So moving to the ninth question. So major problem with tracking and translocation of iron oxide nanoparticles uh, is associated with the inability to distinguish intact Fe3O4 nanoparticles and released ion, which further can be solved by utilizing magnetic particle spectrometry in conjunction with conventional atomic absorption spectroscopy, XRD in conjunction with XPS, TEM in conjunction with XPS, and XPS in conjunction with FTR. So XRD is basically X-ray diffraction, so that is used in finding the crystal structure. XPS I already explained. X-ray photoelectron spectroscopy, basically you have X-rays bombarded on the surface. You get the photoelectrons generated, and the spectroscope measures it. Then TEM, basically transmission electron microscopy, basically it is used in very it has higher resolution than SEM. So you have the electrons being transmitted, and get the image. So basically, it is used widely used in nanoparticle finding, nanoparticle shape, nanoparticle morphology, and there is FTIR. So that is Fourier transform infrared spectroscopy. That is basically used in functional group, finding the functional group. So the answer is magnetic particle spectroscopy, spectrometry in conjunction with conventional atomic absorption spectroscopy. Question number 10. Read the following statements carefully. The ability of nanomaterials to penetrate through hard coating of the seeds and allow water incorporation is the deciding factor for increased growth and vigor. In addition, the seed priming technique with the help of nanotechnology is a promising strategy before sowing. It further corroborates the potential of high yield value crops. Option A is correct, option B is correct, option A and B are false, and option A and B are correct. So basically, let's analyze the statements. So the first statement says that basically the ability of nanomaterials to penetrate through the seeds allow for water incorporation that increases the growth and vigor of the seed. So that is true. Basically, in the second, it is saying that the seed priming technique with the help of nanotechnology is a promising strategy. Before sowing, it further corroborates the potential of high yield value crops. So basically, what the it says is that due to this due to technology, basically you are getting higher yield value. So the number of seeds which germinate successfully is basically very important. So that is why with nanotechnology you can increase the germination ratio that leads to higher yield. So that is the right statement. So the answer is statement A and B are both correct. So we skim through the problems again. If you have any questions, you may please ask. If you don't have any questions, you are free to leave the session. Please. Any questions? Yeah, you can leave the meeting. You can leave the meeting. This is done. Thank you. Any questions? Any questions? So we'll just skim through the slides again. So this is the first question. Basically, Dash is tagged with gold nanorods, that is AUNR, for MRI theranostics and imaging. So the options are gadolinium, lithium, molybdenum, magnesium. The answer is gadolinium. So basically, this is how the uh, work. This is how the working happens. So you have the gadolinium nanoparticles that are coated with drugs, polymers, and target agents. Then it is injected into the body, and basically the MRI system is used for tracking it. So it does the diagnostics and it also does the therapy. Um, Likewise, and the second question, basically, you have compared to monocot plant, dicots show higher uptake of nanoparticles due to more permeability in the roots, permeability in the cuticles, permeability through water channels. So the answer is permeability through the cuticles. And the third question, leaves of monocots have parallel veins that are most resistant to tearing and therefore have high strength, low strength, high permeability, more water pores. The answer is high strength. So basically, these are the three tests that are mainly used. So the first test is the punching test. Then the you have the tearing test, and you also have the mm, shearing test. So basically, uh, if in the case of the tearing test, basically what happens is the major failure mode is crack initiation and propagation. So basically, what happens is the parallel veins do not let the crack to propagate easily, so that leads to higher strength. So that is how it happens. The fourth question is basically what drought resistant plants develop tighter cell walls, cuticles, Casparian strips and other barriers that help minimize dash during dash conditions. So the answer is water loss during low water conditions. And the fifth question, some essential factors of the soil such as organic matter and humic acid make nanomaterials dash which dash. So the options are less stable, conversely it decreases the bioavailability. Ionically stable, conversely it enhances the ionic activity. More stable, conversely, enhances their ability to generate free radicals. More stable, conversely, it enhances their bioavailability. So the answer is D. More stable, it enhances their bioavailability. Um, so, question number six: the transport of copper oxide nanoparticles from root to shoot and its reverse transport from shoot to root takes via xylem and phloem respectively, xylem and water channel respectively. So the answer is xylem and phloem respectively. Question number seven: the significant anatomical difference between dicot and monocot is the leaf architecture, such as the presence of dash in the monocot and dash in the dicot plant, resulting into variable degrees of uptake and translocation efficiencies in nanoparticles. Dumbbell-shaped stomata, kidney-shaped stomata, kidney-shaped stomata, and dumbbell-shaped stomata. Double-shaped stomata, circular-shaped stomata, double-shaped stomata, Z-shaped stomata. So the answer is double-shaped stomata and kidney-shaped stomata. So basically, you can look at the leaf structure. So in nanochemistry or nanomaterial, nanotechnology per se, the higher the surface area, better the efficiency. So here you can see the surface area of dicot leaf is more than the monocot leaf, so that leads to better uptake of nanoparticles. So that is how it works. Coming to question number eight, assimilation and concentration of iron oxide nanoparticles in pumpkin Cucurbita maxima plant, quantified by employing dash to confirm the functional presence in the roots and leaves. XPS Scientification, vibrating sample magnetometer, same. So the answer is vibrating sample magnetometer. So this is the setup of a vibrating structure magnetometer. There is vibration occurring, and the sample is there. Uh, Basically, the magnetic particles are obtained. Question number 9. The major problem with tracking and translocation of Fe3O4 nanoparticles associated with inability to distinguish between intact Fe3O4 nanoparticles and leached ions further can be solved by utilizing magnetic particle spectrometry in conjunction with conventional atomic absorption spectrometry, XRD in conjunction with XPS, TEM in conjunction with XPS, XPS in conjunction with FTIR. The answer is magnetic particle spectrometry in conjunction with conventional atomic absorption spectroscopy. If you have any questions regarding the characterization technique, please ask me. And we have the last question. Uh, the ability of nanomaterials to penetrate the hard coating of the seeds and allow water importation is a deciding factor for increased growth and vigor. In addition to seed priming technique with the help of nanotechnology is promising strategy before sowing. It further corroborates the potential of high yield value crops. Choose the correct option. Option A is correct. Only B is correct. Both A and B are false. Statement A and B are correct. So from the statement, if you look at it, ability of nanomaterials to penetrate to the hard coating basically leads to better results. So that is a true statement. And the second statement basically with nanotechnology you get a higher yield, you get better seed priming. So that is also a correct option. So the answer is statement A and B are both correct. If you have any questions, you can write in the chat box or you can unmute yourself and ask. If not, then we are close to the end of the session. So please let me know if you have any questions. Since there are no more questions from your end, I would like to thank you for participating in the session, and I would we'll meet you next week. Thank you.